Hi, this is Joe Bruno, and I'm just going to go over one problem from Section 3, Problem 18 on the math section of the SATs. This problem states the parabola y equals negative x squared plus 5x plus 6 is intersected by the line y equals negative 1 half x plus 12. What is the y coordinate of the intersection closest to the y-axis? This problem is regarding a system of equations. Here we have y equals negative x squared plus 5x plus 6, and y equals negative 1 half x plus 12. We're seeing where these two equations intersect on the coordinate axis. So let's take a look first at the equation for y equals negative 1 half x plus 12. What is the problem asking? Let's take a look at the trend for this line. It goes through the point 0, 12, that's the y-intercept. It also goes to the point 1, 11.5. That is, if we substitute 1 in for x and then solve this equation, we get 1, 11.5. And then if we substitute 2 in for x, we see that this line will go through the point 2, 11. Negative a half times 2 equals 1. I'm sorry, negative 1, and negative 1 plus 12 is 11. Let's take a look at the other equation. This one's a little bit more complicated. It's going to form a parabola. Its y-intercept is 0, 6. When we substitute 0 in for x, we get 0 plus 0 plus 6. Very simple. And then our next point, if we substitute in a 1, we see that it goes through the point 1, 10. And if we substitute in 2, we see that this parabola will go through the point 2, 12. So we're just looking at a little tiny chunk of this parabola. It doesn't even look like a parabola yet. When we outline it, we see it's just this part of the parabola. And of course, when we start to trace our points for the line, it goes like this. So we see that the point of intersection is here, somewhere in between y equals 11 and y equals 11.5. So graphing these two equations doesn't help us very much, but looking at this picture helps us think about what the question is asking. Let's take a look at how to attack this problem on the actual SAT. We're solving a system of equations. We're finding their point of intersection, so we will set the two equations equal to each other. There's the negative x squared plus 5x plus 6 from the first equation, and we're setting it equal to negative 1 half x plus 12, the second equation. Let's start solving this by multiplying both sides by negative 2. That'll take care of this fraction in front of the coefficient of x on the right side of the equation. When we multiply by both sides by negative 2, we obtain 2x squared minus 10x minus 12 equals x minus 24. Took a little bit of quick multiplication there on both sides. Next, we'll subtract x from both sides, and that will take care of this x here. And so we end up with 2x squared minus 11x minus 12 equals negative 24. Now let's just take care of this 24 by adding 24 to both sides. And when we add 24 to both sides, we obtain 2x squared minus 11x plus 12 equals 0. Let's examine how to continue solving this. When we have 2x squared minus 11x plus 12 equals 0, to me, this is not obvious how to factor. So, of course, we'll be applying the quadratic formula. The quadratic formula is negative b plus or minus radical b squared minus 4ac over 2a, which you must memorize. That is the quickest way to approach these problems, is to memorize the quadratic formula. Are there other ways to solve a formula like this and find the roots? Of course, completing the square, for instance, but that is a very tedious process involving too many steps. Memorizing the quadratic formula is the most efficient way of solving this. It's the fastest, and that's why you are going to memorize the quadratic formula. Next, we simply substitute in all the terms. In this case, b equals negative 11, and a equals 2, and c equals 12. We do some simplification. Careful here with this negative. This is negative b, and b is negative 11, so this becomes positive 11 here. And then, of course, plus or minus negative 11 squared is 121. Negative 4 times 2 times 12 becomes out to 96, or negative 96 in this case. And 2 times 2 is 4. Some simplification, we get x equals 11 plus or minus the square root of 25, which means x equals plus or minus x equals plus or minus the square root of 25 over 4. So x equals plus or minus 5 over 4. So x equals 4 or x equals 1.5. Which one are we interested in for this problem? Up in the problem it says closest to the x-axis, closest to the y-axis, and so that would of course be where x equals 1.5. That's closer to the y-axis than where x equals 4. We're not quite done. It asked us for the y-coordinate, not the x-coordinate. So let's plug x equals 1.5 into the easiest of the two equations. When we plug x equals 1.5 into either equation, we should, of course, get the same answer for y, because this is where they intersect. In the simplest equation, we have y equals negative 1/2 times 1.5 plus 12. So that's a little computation here. Y equals negative 0.75 plus 12. Y equals 11.25. And that becomes our answer to the problem. It was asking for the y-coordinate of the intersection closest to the y-axis. That's how we solve this problem. Thanks for watching.